In this video tutorial, we will cover how to transform data in the Tetrad GUI. To begin with, we must have a data box with a data set. We can either load our data set from outside of Tetrad or simulate it from a model within Tetrad. For now, we will be using a tabular continuous data set that we loaded from a file. Later, we will look at operations that can be performed on discrete datasets or on multiple datasets at once. In order to transform the data in our original dataset, we create another data box as a child of our first. When we open our new data box, we have a number of options for what to do with it. In this tutorial, we will focus on the options in the Conversion of Data folder, although we'll also look at a few other options. There are several transformations that can be performed on a tabular continuous dataset with a single click. We can whiten our data, converting it into a dataset whose covariance matrix is the identity matrix. We can perform a non-paranormal transformation on the data, which will increase the marginal Gaussianity of the variables. We can standardize the data, giving each variable zero mean and unit variance. And we can take the first differences, so that the row values in the dataset become the differences between the row values in the original. In each case, the result will be a tabular continuous dataset. If you perform a first differences transformation, the resulting dataset will have one fewer rows than the original. For all of the others, the dataset will retain the same sample size as the original. If we have a tabular continuous dataset with a corresponding graph, either obtained through search or because the data was simulated from the graph, we can also use the data box to convert our dataset to residuals. If we create a data box with a graph and data box as its parents, Tetrad will automatically convert our dataset to residuals. In this transformed dataset, each variable is the error term that results when we regress the variable in the original dataset on its parents in the original graph. We can also convert our continuous dataset to discrete or mixed data by choosing Discretized Data Set. The Discretized Data Set operation works on continuous or mixed data. For each variable, we have the option of whether or not to discretize, and if so, how. Let's discretize x1. We can set the number of categories to any number we want. This operation will take the range of x1 and separate it into intervals representing discrete values. For each case, x1's new discrete value will be determined by the interval that its original continuous value fell in. We can choose to discretize x1 such that each interval contains an equal number of cases, or such that each interval covers an equal percentage of the range. The breakpoint between our intervals changes depending on which option we choose. Notice that when we choose evenly distributed intervals, our middle two intervals become exactly equal in size. We'll go with evenly distributed values. We now have a discrete x1 while the rest of the dataset has remained continuous. This new mixed dataset can be used, just like our original continuous dataset, for search. We also have the option to go the opposite direction by choosing Convert Numerical Discrete to Continuous. This is the dataset that we just discretized. You can see that the values of x1 are still just zeros and ones, but Tetrad now views those as real numbers rather than binary values, which you can tell because of the decimal points in the numbers. This dataset can now be used for searches that require entirely continuous data. Next, let's look at the matrix operations available in Tetrad. If we have a continuous dataset, we can find its covariance and correlation matrices easily using the Convert to Matrix tools. The resulting matrix is formatted just like a matrix dataset that we might load into Tetrad. It's lower triangular only, with the sample size in the first line. Once we have a matrix, we can perform matrix operations on it. We can find its inverse, assuming it's invertible. If we have more than one matrix, we can take their sum, difference, or average. Because covariance and correlation matrices are symmetrical and are only represented in Tetrad as lower triangular for efficiency, matrices resulting from operations on them may not be lower triangular. If we have loaded or converted a covariance matrix, we can use it to simulate tabular data. The resulting dataset will be tabular and continuous, linear, and Gaussian, and will have covariances according to our input matrix. The sample size will be the same as the size listed in the first line of the matrix. Thank you for watching this Tetrad video tutorial.